Hello friends, myself Professor T.S. Vandali. Today I am going to explain problems related to 1D heat transfer in thin fins. This is one more part left in the thermal conductivity of the 1D one-dimensional heat transfer. So in this, first of all, we try to understand what is fin. A fin is an extended surface to increase the rate of heat removal. So already we had seen many parts in the automobiles. Some parts are having some extended surfaces on the body. So those extended parts are helps to remove the heat from the body. So that extended part of the surface we call it as a fin. This problem is from conduction different from conduction problems, since heat transfer through fins is the combination of conduction and convection occurring within the body. So in the already in the previous problems we are discussed once left side conduction, right side convection, sometimes right side convection, left side conduction. That type of problems already we discussed. This problem is concerned to what we call it as it is combination of conduction and convection. Okay, so in this problem we are going to take an extended part of the fin, means a circular rod, one end is fixed, other end is free. So fixed end we call it as pure conduction, and it is exposed to the surrounding, we call it as it is convection. So in the problem what is asking, find the temperature distribution in the fin as shown in figure. Figure is given. So at the same time temperature T1 is 150 degrees centigrade, T infinity is 50 degrees centigrade, and convection heat transfer coefficient H is given 6 watt per centimeter square degree centigrade. Thermal conductivity of the material is 80 watts per centimeter degree centigrade. Length is 6 centimeter, and the diameter of this circular rod is 2 centimeter. Okay, first of all we must obtain the area as pi r square. So at that time the area it becomes 3.14 centimeter square, and we at the same time we calculate the perimeter of this circular rod, that is 2 pi r. P is equal to 2 pi r, that becomes 6.28. Now we are going to determine the temperatures. So first we try to draw the FE model, that is line diagram. That left side given temperature is 150 degree centigrade, and right side is the free end, and surrounding temperature, that is H into T infinity. So okay, you have to mention. Then stiffness matrix for heat conduction is given by, that is Kc is equal to K by L into 1 inside the matrix 1 minus 1 minus 1 1. This is the standard stiffness matrix for the thermal conductivity. Just you substitute the values of K and cross sectional area and length of the fin, you are getting the value of 41.86. inside the matrix the elements are 1 minus 1 minus 1 1. And similarly we are going to obtain the global convection matrix. Okay, the standard formula is KH is equal to PHL divided by 6 into inside the matrix 2 1 1 2. This is the standard stiffness matrix to determine the convection stiffness matrix for the extended fins. You have to remember this. And after substituting the value of perimeter and convection heat transfer coefficient H and equivalent length of the fin L, okay, we are getting the matrix as 37.68. inside the matrix 2 1 1 2 you are getting. And in the same way we are going to determine the force vector for the extended fin. This is also one more standard formula you must remember, that is FH at the end means at the surrounding, that is convection. So the values are H T in infinity PL divided by 2 1 1. This is the standard formula for finding the force vector. Okay, just you substitute the values of H. T infinity is the surrounding temperature, perimeter L, you are getting the values as 5652 11. This is the force vector. And once you are knowing this conduction matrix, then convection matrix and force vector, already we are knowing the standard equation global stiffness matrix is given by, that is K is equal to Kc plus Kh. Already you are calculated. You add these stiffness matrix, you are getting the global stiffness matrix. Once we are getting global stiffness matrix, so we are going to substitute in the equilibrium equation, that is Kt is equal to F. Similar, this formula is similar to, it is bar element, that is Kq is equal to F. Okay, here T is nothing but temperature vector, K is the equilibrium stiffness matrix, F is the force vector. Just in this you are going to substitute the values of equivalent stiffness matrix and temperature vector and force vectors. Okay, this is the Kq is equal to Kt is equal to F. And in the problem, specified temperature T1 is given 150 degree centigrade, and we consider the in the Kt is equal to F, second row. So we are getting the equation 117.22 T2 is equal to 5652 plus 4.8 T1, and after substituting the value of T1, it is given, we are getting the value of T2 is equal to 54.35 degree centigrade. In this way we are going to find out the temperature at the node, that is T2 is equal to 54.35 degree centigrade. Thus the above matrix can be modified as, so 100,117.22 and T1 T2 is equal to the force vector 150. It is given temperature T1 is given, force vector we take it as at node 1 is 150, and at node 2 that value we take it as 5652 plus 4.8 into 150, and after reducing you are getting the below matrix in this matrix form, that is K is 100,117.22 T1 T2, that's equal to 150, and temperature force vector second force is 6372. So this type problem is asked in the previous question papers many times, so you concentrate. It may be a circular extended fin, or maybe a rectangular fin, so you concentrate more on this type of problems. And next class I am going to explain about the extended fin with insulation. So please all of you go through this, and tomorrow I am going to send you the assignment questions from all the 5 modules. All of you try to write the assignment in your notebook. Suppose A4 size papers are not available, at that time just you write it